In this video, we're going to look into something that is known as heat of neutralization. Now, it is something that belongs to thermochemistry, and it is a very, actually not really that difficult, okay, because there is a pattern for the other kind of reactions as well. So, heat of neutralization, something that's related to thermochemistry, the study of heat and chemistry together. Now, let's get to know what does it mean by neutralization. Firstly, neutralization is the reaction, or what you call the name of the reaction that we have when we have an acid reacting with alkali, but sometimes it is also known as base, but most of the time I would say it's more likely alkali is the one that everybody is more familiar with. So acid react with alkali that gives you salt and water. The one that most of the teachers just keep on repeating themselves. That sounds so, I don't know, maybe, I think it should be quite easy to say yourself. If not, then try to say it 3 times again. Now, here's the thing. Acid and alkali reacts give you salt and water. So how do we define acid? Acid is always known as a thing that has hydrogen ion, and then alkali is always the thing that is able to produce hydroxide ions. So when these two ions combine together, that's why they will give you H2O, aka the water that everybody knows. So when these two things combines together and gives you water, this is also known as the ionic equation. That most of the reaction they will say that, okay, the reason why this is a neutralization reaction, because most of the neutralization reaction, their ionic equations are surprisingly the same, which is hydrogen ion reacts with hydroxide ion, gives you water. And this is, of course, one of the questions that I guess that they might ask you outright, the ionic equation to produce, for the neutralization reaction. Or probably they might ask you to write the chemical equation to for the reaction that you have during your questions. Okay, let's say, for example, they give you not two acids, okay, two substances, okay. Let's say they give you an acid and alkali, okay. So, for example, like sodium, hydroxide, and also, let's say, I don't know, maybe sulfuric acid, okay. So, just write the corresponding so that they will form and just write the water. If it's difficult for you, writing the chemical equation of water should be the easiest one that you can have. Now, of course, in the process of neutralization, they will experience what? They will experience heat change. Now, in a chemical reaction, the heat change, it can be leading to releasing heat to surrounding, or you are absorbing heat from the surrounding. So releasing heat to the surrounding and absorbing heat from the surrounding, they will actually tell you what is going to happen. So how do we tell that whether the reaction is releasing heat or absorbing heat? Here's the fun thing. Heat change is known as Q in most of the equations that we are writing, and based on what you had learned in physics, Q is equals to mc theta, which is also known as the mass of the solution. In our case, we are having acid and alkali, multiplies the specific heat capacity of the substance we are looking at, and lastly, the change in temperature. So when we have all these things that they will tell us the heat change, of course, it's still not good enough to tell us what is happening, because what we are going to always have, we are going to have a positive value for our heat change that is always happening. Now, what we need to do next is know the difference between releasing heat to the surrounding and absorbing heat to the surrounding. What kind of observation? Here's the fun thing. When heat is released to the surrounding gains more heat, which is why when you touch it or when you're holding it, But of course, it's not really something that I would recommend you guys to do it for certain reaction, because they might getting too hot or too cold, which might injure your skin. So releasing heat to the surrounding, when you touch it, okay, you will feel warm. Of course, some of them you might feel hot, but yeah, to us, to chemistry, we only get the idea of, yes, this reaction is releasing heat to the surrounding. Of course, while on the other hand, when the reaction is absorbing heat from surrounding, it should feel cold. So that's the concept. Now, what comes next is the things that you need to do in here. When, let's say, you have a solution, you have, actually you should have two solutions. Let's say one of them is the acid, the other one is the alkali. What you have to do is definitely measure the temperature of two things. Both solution. Okay, there is a must. Okay, when you try to measure and when you are trying to record them, okay, the standard procedure of this thing, it should be, first thing, record the initial temperature of both substance. First thing of acid shall be, let's say, for example, the thermometer is telling you that, it's 29.0 degrees Celsius. Now, here's a little tip that everybody should take note. It has to be something that has 1 decimal point. Okay, it is a must. Now, while on the other hand, the other thing, the alkali, yes, you also need to do the same thing. For all the thermometer reading, they will always have 1 decimal point. Now, let's say if it is so lucky that you have 29.0 degrees Celsius as well, congratulations. Then, what is going to happen? We always need to have the average initial temperature, because it doesn't sound fair if you use just one initial temperature of one substance only. Okay, isn't it? So, which is why we need the average initial temperature of our reactants. In here, it shall be 29 plus another 29 divided by 2. Luckily, we shall be 29.0. However, if it is really that, that tricky, perhaps it gone up to, maybe a 30, then in that case, the math still works. There shall be 29 plus 30, that shall give you 29.5 degrees Celsius. Remember, in practical exams or experiments, units are important. The way that how you record the data is also important as well. Now, here's the next thing. After you finish measuring the initial temperature, the next thing that you need to do is mix your acid and your alkali into somewhere. Okay, now when you mix them together, make sure that you have your thermometer in there to record the final temperature of this thing. Of course, the final temperature is referring to the highest temperature that your thermometer is able to give you. To remember, that is the value that you need. I don't know, maybe it says that, okay, it is able to reach up to 34.5 degrees Celsius. Now, here's the thing. When you are trying to read thermometer reading, of course, most of the time the school will provide is actually a mercury thermometer. Now, they won't be able to tell you exactly whether it's 0.5 or not, okay? But, well, if you are able to see that if your mercury is actually reaching up into the middle, just like this one I'm drawing, well, just go for the 0.5. Of course, you might be saying that, teacher, I don't think it's 0.5. I think it's 0.4, 0.3. Stop being silly, and that is the point that some of us are trying to act smart. Try not to do that. So in other words, what I'm trying to tell you, the way that how you record your initial temperature, the thermometer reading shall be only 0 or 0.5. Okay, that's probably the only two values that we are going to get. Now, after you finish recording all the necessary values that you need, the next thing, the rest of the thing is proceed to the calculation. Now, as you can see, the heat change in here, what you need is mass of the solution. Now, the mass of the solution actually is going to be tricky because some of us might be thinking, if you need a mass, then you need the electronic balance, all this sort of stuff. However, the good part or the best part about thermochemistry is the volume in centimeter cube is actually exactly the same as the mass of the solution. You can use straight away, okay? But of course, provided it's in centimeter cube. The next thing that you need to do is multiply with the specific heat capacity of the solution. Remember, there's the specific capacity of the solution is going to be remain as a 4.2. In case, one of the questions that I suddenly came into my mind is why are we using 4.2? The reason why is because we are assuming that the solution is actually having the same specific capacity as water, which is the reason we are using 4.2. And lastly, the temperature change. Find the temperature minus the initial average initial temperature. So that is exactly what you need. Now, are there anything else? Oh yes, there is. This is only the first part. Now, this is not really the heat of neutralization. The heat of neutralization, let's look into here. Heat of neutralization actually needs another one more step, which is you need to divide the heat change, which is the Q that just now you found previously, by the number of moles of water that you are able to produce with a given amount of water, acid and alkali together with the concentration that they had just now. Now, this is actually related to stoichiometry, which I hope you had already know that how to determine the number of moles of water based on the chemical equations that you had written previously, which is why I highly suspect that they will ask you to write chemical equations, perform calculations to find out the number of moles of water, maybe the water or maybe the acid, maybe the alkali, but no matter what, determine the heat of neutralization. Will always need information for heat change, which I shown you in here, and divide with the number of moles of water based on the number of moles of acid you had and the number of moles of alkali you had. So after that, you will find that there's a value which probably I would say that is quite big. Maybe there's like, I don't know, 5 figures. There's a 5 figures that you might have, and then according to the rules in quite a lot of examinations, you should write all your answers in 3 significant figures. 3 significant figures, and then after that, convert those values into kilojoule per mole, because most of the answers that you might have, I don't know, most of the students, they will straight away get the answer in joule per mole, which might look a little bit ugly, but most of the answers for thermochemistry, they are written in kilojoules per mole. Now, the final touch, Here's the very, very teeny tiny tips, Most of the students, they didn't do this, and then that's the reason why they got deducted. Their marks deducted, like, I don't know, maybe 1 or 2. So here's the thing. At this point, determine heat of neutralization. It becomes very crucial that you need to mention whether the values are positive value or negative values. Now, the logic behind this is speaking about if somehow your temperature is dropping, put a plus. If your temperature or the surrounding temperature is increasing, or let's just say that your thermometer reading is increasing, then just put a negative sign to it. This is because the negative sign is mentioning or trying to imply the fact that the system, or you can say the reaction, is losing heat. If it is increasing, then that's why a positive sign. Then this fella, it should be okay. And endothermic reaction, exothermic reaction, and endothermic reaction. The temperature for exothermic reaction increase. For endothermic reaction, it will decrease. However, here's I think this is a very nice tips for everyone. Neutralization reaction will always be exothermic reaction. So remember to put a negative sign for before you finish your answer. So anything else that I can say before I end this video? Just be careful, know what you are doing, write all the chemistry tests involves finding number of moles, writing chemical equation, perhaps an ionic equation as well. Know what what does the value means, and figure out what kind of yeah, you need to know how are you supposed to read the instructions and follow what they are doing. So all the best for your tests and or exams or the exercise you're doing. I'll see you guys soon. Goodbye.